All right. This is pretty fun, right? It's been a cool day. Really nice to see everything and all the passionate people here. But if I am being honest, I got a bit of a confession to make. I have nothing to compare today against because this is the first conference that I've ever been to, let alone something as big as KubeCon. Picked quite the interesting spot to put myself in for my first day, which is nerve-wracking, but help me out. Who else is in here for their first time? Okay, most of the room. That makes me feel way better. Thank you. Look at us getting out of the house. That's pretty sweet. My name is Carson Culler, and I'm a DevOps engineer at Liatrio. Today I'm here to talk about how Argo CD behaves at the edge in high latency and even disconnected environments. Now, I'm sure we're all huge fans of the tool here, and I'm certainly no exception. You know, we all know it and we all love it. This is a B. Those are its knees, and that is Argo CD. I'm going to move on. I think you all know where I stand on the tool. But what if I told you that one of the big reasons why Argo CD and GitOps in general are so great is because of some underlying assumptions that are typically only safe to make in the cloud. Those assumptions are that Argo can talk to Git and container images can be pulled. Now, it's safe to make those assumptions in the cloud because in the cloud, we have guarantees for things like availability and connectivity. To put it simply, workloads in the cloud can talk to the internet, and they can talk to it quickly, and that's a guarantee. So what happens when we strip away that foundation? We no longer have those guarantees to rely on. Well, we actually start running into some really interesting problems that we'll get into in just a moment. Let's talk about how running Kubernetes at the edge can shake things up a bit here. This entire talk holds true for all edge or on-prem Kubernetes clusters, but to really drive the point home, I like to focus on those extremely rural settings like the ocean. Fun fact, Argo was named after a ship, so it's actually kind of a fitting example. So let's say that we have a Kubernetes cluster running on a boat in the middle of the ocean. Why is that problematic? What does internet connectivity even look like in that part of the world? Well, it looks like this. When you're on your boat in the middle of the ocean, and you want to connect to the internet, your signal has to get relayed through a satellite in space that then forwards it to where it needs to go on land. And this works great. This works perfectly fine until, this happens. Or worse, this happens. Or even worse somehow, this happens. Look, I'm going to assume that if your ship sinks, your machine going offline is the least of your worries. But the point that I'm trying to make here is that without those luxuries guaranteed by the cloud, the physical geographical environment now plays an effect on our workload's abilities to talk to the internet and to talk to it quickly. So let's assume that Argo is running on a cluster in one of these environments, and the cluster's offline. How does that affect the tool? This might come as a bit of a shock, but Argo kind of needs to be able to talk to Git. If Argo can't reach Git, then it has no desired state to compare resources against, meaning it can't reconcile drift in our cluster anymore. So this is a big and frankly obvious problem, but actually there are three. The second problem has to do with cluster dependencies. What happens if we go offline right after a sync, before images have finished being pulled? Well, depending on what happened just before going offline, this could potentially leave our cluster in a really broken state. And speaking of which, the third problem is rollbacks. If our cluster is offline and unhealthy, then we likely can't fix anything forward, and Argo doesn't cache things forever, so the likelihood of us being able to perform an offline rollback is pretty low. So to sum all that up, when the cluster is offline, Argo can't sync any changes. Any changes that it is able to make might break, and if they do, we probably can't even roll them back. So the question then becomes, how do we help it, right? How do we help give Argo the guardrails that it needs so that it can continue to do what it does best, even in an environment that isn't very conducive to what it does at all? That was a question. Does anybody know? Because I would just kidding. So about a year ago, we were designing a system fit for the edge that could run in these environments. Not necessarily air-gapped, but sometimes air-gapped. Not air-gapped on purpose, we'll call it. Anyway, we found that there really isn't very much guidance out there for how to support Argo in these situations. I mean, at the end of the day, none of this is Argo's fault. It has everything to do with where it's running. Those problems that I've been talking about, they don't exist in the cloud, right? They're esoteric. But at the edge, they're very real, and they're very common. Now, I'm not saying that we found the end-all be-all solution, but the one that we wound up at is elegant, and I think it's worth sharing. It allows us to retain all the benefits of Argo CD, but without having to rely on those luxuries of the cloud. But last thing here, before we dive into what we set up, I just want to take a few minutes to just pull back the curtain on how Argo actually makes changes to our cluster. That way, we're all on the same page about what the underlying problems even are here that we're trying to solve for in the first place. So when Argo makes changes to our cluster, there are typically three things that need to happen. First, there's the refresh. That's when it pulls in new updates from Git. Then there's the sync. That's when it deploys those updates to the cluster. Then any new container images need to get pulled. And then once all those are done, pending no unrelated errors, our application will be running and up to date. So let's talk about how those failure modes from a moment ago affect this process. Our first failure mode was not being able to talk to Git, which is going to kill our ability to perform a refresh. Now this is bad, obviously, but it's not actually the end of the world. Sure, Argo won't be able to reconcile drift, but if there is no drift and our cluster is already healthy, then things will continue to run just fine. It's that second failure mode that's the big one, pulling images. This right here is the crux of our problem because it means that any arbitrary change that Argo makes now has the ability to break our cluster, and that cannot happen. We need to be confident that Argo's changes will be safe and reliable, right? We can deal with failures before changes are deployed to the cluster, but failures after changes are deployed are unacceptable. So what if we just move the ordering around a little bit? So that way those scary parts happen before Argo deploys changes. I mean, look at how easy that is. We just swap two rectangles around. All jokes aside, this shifts the two failure modes left so that they are encountered before Argo is allowed to deploy changes to the cluster. Obviously, we can't rewrite the actual sync and refresh logic, but what we can do is ensure that manifests and their images are on the device before the cluster actually needs them. All right, the moment I've all been waiting for. Let's take a look at the solution. I forgot a slide, but I just said all that, so it's okay. Everything just works. All right, let's take a look at the solution. So the first problem that we need to solve is the Git availability. Argo needs to be able to talk to Git. Well, if we're worried about Argo being able to reach Git from on the cluster, what if we just moved Git? Now, I don't mean change where we commit and push code to, but what I mean is move Git out of GitHub or Bitbucket and into a location closer to Argo. To solve this, we ran git on the machine right next to Argo CD, configured it to be a pull-through mirror for upstream GitHub repos. That way, it can try to pull in changes on an interval, and if the cluster is offline, it'll just fail gracefully. From there, Argo can be pointed at those local repo clones instead. Just like that, we've solved problem one, and Argo now has a guaranteed connectivity to Git as long as those pods are running. Now let's solve the images problem. There's a few moving parts here, and we used a combination of Zarf and Crane to solve it. As part of our release process of our static Kubernetes manifests, we grab a list of all container images, pull them, bundle them up, and shove them in a container registry. Then on the machine, we have a job that runs that queries git for new revisions, and if there are any, it'll attempt to pull that corresponding bundle onto a registry on the machine next to the cluster. Now, obviously, those two have to happen when there's an internet connection, but here's the kicker. We have an Argo CD pre-sync hook that verifies that the correct revision is in git and the corresponding image bundle is on the local registry before it's allowed to deploy changes to the cluster. Just like that, we've solved problems 2 and 3 and can now perform both a sync and a rollback even while air-gapped. And then finally, because we've introduced some pretty important services here, we've configured K3s to store its internal data on the file system, so that way we can safely retain the cluster state and data across restarts and updates. That's pretty simple, right? Not very much. Obviously, a lot of these tools can be swapped out for alternatives, but these are what we went with due to their reliability and the fact that they're open source. All right, closing thoughts here. What do I want you to take away from this? That solving things at the edge isn't easy, right? It comes with a whole new problem set than what the cloud provides. But it's where we find out what our tools are really made of. Because the moment that we stop saying that won't work here, when we start asking what would it take to make that work here, that's when real innovation happens. That's how we take a tool like Argo CD, which is built for the cloud, and we make it sail just as smoothly in the middle of the ocean. That's how we take these monumental things like GitOps, and we push them forward in the industry. And in this case, literally to the edge. Okay. Thank you all very much. I really appreciate you taking the time out of your day to listen to me talk. If you like this, feel free to check us out at Liatrio. We are a collaborative technology consulting firm, and we're passionate about transforming the way that you deliver digital value to your customers. If you're solving a problem and you'd like some help, hit us up. We'll pull up and chat. Thanks, guys.